Next piece of line is the pulley arm casting, and I am going to try to do all the castings before I get into the machine parts on this, so that's why all you're seeing right now is cast work. First step in the process is to remove the parting lines, any gate flashing, and just try to make heads or tails out of exactly where to start. Clean this up, blast it so it looks like it's never been touched, and we'll go from there. Minimal mismatch in the two halves of this particular part. This is a little oblong, so I'm going to have to round that off a little bit better with a file. And there is an asymmetry here. Let's see if we can see it. There you go. This side is considerably bigger than this side. I'm sure that's not by intent, because on the print everything is symmetrical about this hole. So I'm going to have to be careful how I hold that as not to get jammed up on that particular feature. Hey, quick question or quick comment before I continue with this part. I was recently at the California Bar Z Summer Bash at Stan Zakowski's place, and thank you, Stan, and to all the sponsors that made that event possible. I walked away with some swag and met a lot of great people. It was nice to meet you guys. I had some people say, hey, I was once subscribed to your channel and now I'm not. What happened? Well, I don't know, but I heard that from more than one person, and more than one person said that that's been happening to them on other channels as well. If you believe that you're a subscriber to this channel, please double check that. If your subscription has dropped off, please be kind enough to renew it. I would greatly appreciate that. All right, let's take a file to this piece and make it look like something. I will probably fast forward that if I show it at all, but I will come back and show you what a little bit of elbow work can do. Stick around. After about an honest hour of filing this little part, I think I've successfully removed the gates, cleaned it up somewhat. I'm okay with the way it looks at this moment. Now I got to figure out how to hold it. If these surfaces in the back here where my thumbs are sitting, my thumbnails are currently touching, if they are offset this way, it will make this a lot harder to hold, but not impossible. I'd like to locate from the rib so I can find the center of it, and ideally it has to be machined probably in this orientation. I need to cut this off, drill 2 holes, ream a hole, then I can probably flip it over easily, strapping it down, just that. And yes, it could be machined all 3 surfaces from this orientation, but that does not assure that you have the center to center that the print calls for. So this is, although it's a very basic little part, it's a part you got to look at and be careful with, or you're going to get stuck. So let's get over to the machine, figure out how we're going to hold it, get it done. I like it. Okay. All right, how about a little bit of behind the scenes before we actually start throwing chips? Many of you have commented on the philosophy of holding a casting is just as important as machining the feature. So on a part like this that's not only asymmetrical, but pretty much everything is tapered and there's no good place to hold it, let me tell you what my thoughts are on this piece. We have to establish, look at that pointer, is that beautiful or what? Thank you, David. We have to establish a height from here to here, okay? And we have to establish a center line from this boss right here to a usable section of this plateau. Now, when I mean usable is you want your screw heads to be somewhere in this vicinity in here and not coming up halfway through this, because it's a through hole, not a threaded hole. So to keep track of those little usable squares right there and right there, I read out the other side. So this is strictly visual now. I want to center this. And by having this, I'm going to hold this on the only flat areas that there are, and that is this area right here, from this bend in the L shape on both sides. This is a very soft material, and it's not a very aggressive cut, so that is more than sufficient grip for what I'm about to do. And my rule of thumb is when the chip exceeds the grip, the part is going to slip. Gone. Anyway, okay, now we're back. Now we're serious. I'm going to take the pointer of the machine. I'm going to put the pointer of the machine down in the center of this boss, and I'm going to move over the required dimension on the print, up and over. I would like to see the machine come back down in this region, preferably right dead center of that square would be ideal when I'm at the required dimension. If it falls somewhere in the red zone, that means the part is laying down too much. Because you can see the more it lays down, the further away this area gets. So when I find the center of this, because this needs to be machined flat and so does this, it is dealer's choice right now where this rotation is. So for sake of my build and for sake of my sanity, I want my screws right there. So I'm going to play back and forth holding this. I'm going to come down from the center and move over, and I'm going to continue to bump this in between two pieces of aluminum until I like what I see here. And I'll do the same thing with it side to side. It is close enough. I squeezed it in a vise, trammed the vise, measured the boss. It's about 7/1000 of an inch off center, but I think I can live with that. So I'm going to center it up as well on this and come over here and move the required offset. And if there is any difference, it'll be in the wall thickness from the edge of the hole to the outside. Same thing on this side. All right, that's my philosophy on doing that. And you can see where the red defines usable space. I think that's a very handy trick. And that's how I'm going to do it. The outside does not need to be machined, so an inverted approach gives me access to all the sides I need. This surface right here, the through hole, deck this surface, and two mounting holes there. And technically this part would be done. Let's put it on the machine and put that into practice. Do it. The setup I'll be using is the edge of a previously used fixture. I believe I made some, it was either the drill press or the engine lathe, the small scale engine lathe I use these jaws for. They are off center. They are being held in place by a relatively stout spring right here. And that allows me to put the pressure of the part in the middle of the vise. If I were to span the gap in the vise, it would put the pressure over here, and it's never a good idea for offset pressure on a vise. So try to work in the center if you can. That's what I'm doing here. The part will sit in there as such, and will probably be flush or close to it by the time I'm done correctly locating this part. The reason I have the spacer plates is so that I can mill the part down with it below the surface of the hard jaw. Let me put this on a tripod and you get a better look at the fiddle factor it's going to take before I can actually take a cut. The top of the part is relatively flush with the two spacers, and you got to start somewhere, so that's where I'm going to start. The pin currently in the drill chuck is the size of the through hole on the small end. Now, although it's relatively difficult to see this down that low, I will do the best I can here. Visually, the 125 diameter pin, 3mm diameter pin is lined up with that boss. Now let's take a walk and see what we get. My digital readout is 00 at this point. The required shift is 812. And that is just a little bit more than 20.5mm. That is surprisingly close to being not bad. That's actually pretty good. I was kind of hoping it would be out grossly so that I could shift it, show you the difference. Oh, and I'm going to shift it and show you the difference anyway. If it was that easy, hell, why not? Okay, I just pulled the bottom of it towards me. It just moved this way. Let's go back to the 00 on the digital, reestablish everything. Since the bottom pulled out, the X changed considerably. Now let's repeat the first step and show you where 812 hits. Okay, 812 hits right. That's about a third of the way into this pin. Now this pin is oversized from the hole that's going to go in there, but it probably represents the head of the cap screw I'm going to use fairly well. Let's pull this off and show you that from the front. I think you can see that would be a catastrophic failure when you flipped it over and realize that your tool is tickling the inside of the casting. You definitely want to be a little bit further this way. Which means if I kick that boss down there this way, which way? That way. Now I can't tell. This way it's got to go. That will move these holes over accordingly. So let's do that. Let's go back to the original setup. Called good. But you see what I'm getting at here. Next thing to worry about is, depending on how far this was rotated, about, let's say there's an axis running through this corner right here. As it swings about that hinge point, the distance between this top surface and that bottom face increases. As it swings forward, as it swings this way, it decreases. As it swings this way, it increases. This face to that face down there. So that's the next thing that's got to be checked. And when everything falls within allowable material, I will put some cutters in and we will make some actual chips. Stay tuned. I am very confident in the orientation of this part right now, and the first step will be to put the flats on. Now, anybody that's ever worked with castings know a casting profile can change as you mill it away. So double check the alignment of the hole on the bottom here to the location where you want your holes to be after the fact. It's a very superficial cut. I don't expect much of a change, but it's always good to be safe. All right, let's get some drills and reamers, finish this part up. End mill first, of course. With the part mounted vertically, I'm going to take a light dust cut on the top surface here, move the cutter down to that face right there. When they both clean up adequately and to spec, I'll call it a day at that point and drill the holes. When I hit the required depth dimension to go for this face right here, I was still shy. So I've exceeded the dimension from the top surface to this face right there, and I will reset the cutter to 0 here and move back up to now establish the distance between those two planes. Once that surface cleans up completely, that is. And sorry for the awkward camera angle, there's just no easy way to film that. All went well. Those surfaces are now parallel and to spec. Time to put the drill chuck in, drill and ream, 2 clearance holes up here, and this part is done.
Note to self, stop drilling when you see wood, and definitely stop drilling if you see cast iron. All right, that piece is done. Let's put it on the bench, take a look. The one feature I was really focused on was the placement of those screws. I wanted them to come through clean without having to interfere with the vertical casting, and that's exactly what I achieved. Symmetry on the bottom is pretty good. Let's pull that out for a second. Symmetry on the bottom is pretty good. I like it. The alignment of this hole, I would say, influenced by a shadow in the machine. My bad on that one. I'm about 10th thou off center on this boss, but wait till you see this. Watch this. Boom. How's that for asymmetrical? Trying to figure out exactly what's going on here. You hold the bottom square, you can see the back tilt to that, at which time this wall moves in as it bends this way. Had I positioned that vertically for a cleaner concentric relationship, you can see by the line in the bench what would have had to happen to that bottom face. And in doing that, that would have moved these holes closer to this casting and caused a real problem. So you got to take what you get, right? I am less than pleased with that result right there. But maybe I'll just put a big washer or something on the outside of the shaft that goes in there and hide that. Who knows? You know, you got to work with what you got, guys. I am taking full credit for this one, full responsibility for everything that was lined up. These were more important than that. And as far as I have, as long as I have control material there to hold that shaft, I'll be all right with that. Those were the most important. You know, the more I look at this part, the more it tears me up. There is just nothing worse than a small problem that might not mean anything in the big picture, but boy, I tell you, that is just eating me up looking at that. I have looked at this thing 15 different ways, and I'm just telling you, taking care of that is just doesn't look like an option. If you look at the outside edge here, right here, that surface right there. Watch this. Watch the angle between the outside surface and the inside surface that was cut. All right, that top looks pretty flat, and now that bottom looks like it's severely slanted in towards that hole. Yes, I'll give you that. I formed the outside surface because that was a large casting gate right there. It's round, relatively. A whole lot better than it was. And that's relatively round too. Now that could be moved in about 10 or 15 thousandths, maybe a quarter to a third of a millimeter. But if we were to make this a square corner right there instead of an angled corner like it is, that means the back would have to tilt back this way. And when it does, these two holes move in and the heads of the screws would interfere. So it's just, it is what it is. I'm not 100% happy with this. It is functional, absolutely. It is to print, absolutely. Is it visually, cosmetically attractive? No, it's not. Is it something that I'm going to be able to live with? No, it's not. I'm going to contact the company and I'm going to get another one of these, and I just got to believe that there's a better combination of features to be had from this casting. I'm just looking for a place to start, and since nothing is square to anything else, the underside of this casting here is not parallel to the back surface. It tilts in, tilts down. At least I know exactly what I did before, and I will have a place to start. Anyway, there you go, man. Write that one on the calendar. Sometimes you just you got to make lemonade out of lemons, and this is one of those pieces. But I'm just not going to settle for it. Going to get another one. Going to make another one, and sometime in the future I'll show you what that one looks like. But as for now, this is the end of this video. Thanks for watching, guys. I hope that the swing in the part here gave you some idea on how to move holes around if you have to. Those holes came out nice, but this one, good Lord. Anyway, don't cry over spilled milk, right? Get another one, do it again. No harm in failing. No harm in not having it perfect on the first try. It's not, and if it's not up to your standards, don't make do with it. Do it over. That's all I got to say. All right. Thanks for watching, guys. Joe Pye here at Advanced Innovations in Austin, Texas. Stay well wherever you are in the world. I'm out.